Hello and welcome to part 2 of Dev Maths and Stats Refresher Course, Lecture 7. So we finish off these problems on summation notation before going on to probability. So we're getting to the ones now that are slightly harder when we're looking at figures from this two-dimensional table. So first up here is question 4. So we're summing values of z. Okay, to start with, just like I started here, there's no operation going on with this z, so you're just going to add the z's up. So it's just a matter of knowing which ones we're talking about. And this here means that we're going to go from I from 2 to 6, and then from j from 3 to 8. So this is a really neat way of looking at writing it, but we need to know what it looks like when we write it out in full. So I'm going to put it in down here. Make sure it's visible. So what exactly is this clever piece of notation bundling together? Well, what you've got here is you start off with I is 2 and j is 3. So you're just looking at z 2. You can put a comma in to separate them. z2 3. So z2 3 is kind of here. That's 870. z2 3. So you start off with that 870, and then what you do is you keep the I at 2 and just move the j from 3 to 4. So now we're going to z 2 4. So that's the 2 4. That's onto the 1080. And then you go to the next one, the next one, the next one along here. So you go to 3 4 4 4 all the way up until you eventually come to j gets all the way to 8. To say here z is equal to 2 8. Oh, what a strange 8. So now you come to here. So far you've added up from 2 over here. From 2 3, 2 4, 2 5, 2 6, 2 7, 2 8. Okay. If you're old enough to remember typewriters, what happens now is like a carriage return. You come to the end of that row. So with this value of 2, you've done all the possibilities for j. So now you reset. This now goes up to 3, the next value of I, and you start again with j is 3. So it's plus. This time you're on z3. Sorry, no, I is 3, so z3 3. So that comes to 3 3. So now you're here, the 550. Oops. And then you go on to plus z of 3 4. So with I is now 3, you go through the whole thing again with j until j eventually maxes out again over here at 8. So you're going up to 8 with the j's. And then you keep going. Now you take z is 4, z is 5, z is 6, z is 7, and eventually you get down to the very bottom row where I is coming up to 6. Sorry, I is coming up to 6. Just want to make sure it's clear that there are several rows here, blah, 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 and eventually you come to z I is 6, and start again at j is 3, plus z 6 4, plus z 6 5, 6 6 6 6. And finally, the very last one of all, I has got to 6 and j has again got to 8, so you get 6 8. You've added all those together. So what you've done is you've started here, gone along this row, then this row, then this row. So you end up down on the 6 8 here. So you've added up, I think it's those numbers there. So you add up that lot there. So it should be simple to get this from 2 to 6 and 3 to 8. So it should be simple to get the answer in Excel because there's no operation to be done on the elements. We're just adding them. So it's going to be quite a big answer, I think, because there's a lot of numbers being added. Let's see, from here to 8, and then from 2 up to 6. So I is going from 2 to 6, and j is going from 3 to 8. So we've got 21,390. Yeah, so it's got a big number. 21,390. Okay, which brings us to the final one. And in the final one, you've got some more fun, because now you've got interaction between the stuff happening in this the 10 by 10 table and the one-dimensional vectors. So again, I'm going to first show you what does this thing look like when you write out in longhand, and then how can you kind of practically calculate what this is going to come to as a sum. So first we're going to again need to grab hold and just copy it, like so. Hey, look, I make sure that I forgot to tell you after everything, I'd be boring and tell you, make sure you don't just sit there and chill and watch me do it. You should be stopping and making sure you can do it before each step. So now, I hope you're coming back, having tried hard, and scroll down a bit here. Having tried hard and got it sorted out yourself. Okay, let's put a space. Okay, so kind of get the sort of geography of this to start with before you worry too much about the operation. Which values are we talking about? So we can see that I and j are going all the way through from 1 to 10. So for the j's, for the y, which is in this list, we're going from 1 to 10 every time. So for the y's, we're just looking at the first 10 here. We're not going to use these ones. We're using these numbers here. And for the z's, we're using all of them, because z is going from 1 to 10. I from 1 to 10, and I from 1 to 10, j to 1 to 10. But let's look in a bit more detail what it looks like. So what the first term then is going to be 1, 1. So z 1, 1 times y 1. So you want to multiply this 810 times 15.4. So it's that one times that one. Then you go to z. So these z's are going to go like this pattern. So z 1, 2, and this is y2, because the letter on the little letter here on the y is the same as the second one on the z. So that's increasing as we go this way. So 1, 1, y1, 1, 2, y2. So that's looking at this one times that one plus this one times the second one plus this one times the third one. And we keep going till we come to z1 10, which is 820 times y10. So as we go across here, ooh, we don't want to do that. As we go across like this, we're going down here, multiplying the numbers together, which is going to make it a little bit awkward when you actually physically calculate it, which is a shame. I have to adjust things. Let's not get ahead though. So we go right across here to y. No, we've got the z. Let's convert this into a z. Z1 10, y10. Then we switch to plus. We go to 2, so 2, 1, and then everything else is the same. Plus z 2, 2, y2 plus z 2, 10, y10. Because y is only a column, you're using the same values of y again and again. So as you go along this second row here, from along here, you're going to again be multiplying by these numbers, going this way and this way. And you keep doing that for each row of z. So every row of z is multiplied by the column of y, a bit like you're doing kind of a matrix product kind of thing, or multiplying a matrix by a vector. Sort of what you're doing here. This is the matrix, this is the vector, until you finally get to the bottom row and you multiply that again. So let's get to the whiteboard. So the bottom row of this is z 10, 1, y1 plus z 10, 1, y2 down to the very bottom corner one, 10, 10 times y10 again. like so. Okay, so there's lots of different ways you can work this out in terms of practically calculating it. If we go to the spreadsheet now. The reason it's slightly tricky is that you want to go along this way, but multiply by numbers that are like this, which makes it a bit tricky. But if you look at the formula, there's a bit of a shortcut you can do. If you notice that looking down this way, if I add all these numbers up here, if I add these together, then I can multiply by y1. Then I can add these numbers together and multiply y by y2. Add these numbers together and multiply by y10. That'd be slightly quicker. So first of all, what this is doing is it's really adding up the columns. So I'm going to add the columns of z as the first step here. We'll come to this again in a minute. We'll do this again in what part of the probability actually. You'll find this happens again, summing up the columns. So that's the z columns. So the z column totals look like that. And now here's another good, this is simply going to be the yi's, because we need these to be in vector terms transposed. So this is yi transposed. So what I'm going to do is I'm going to get the first 10, which is all we need. You copy this, so copy that and put it here and paste it in, but you choose paste special. I'm going to choose this one actually, but well, okay, that's the one. This is called transpose. You can find it on paste special menu, but it's come up in the shortcut there. So if I transpose, it's going to paste them in like that. So that's a really good way of getting something from a column and pasting it in as a vector. It only works. Sorry, I need a drink of water. Okay, sorry about that. It only works if constants. If there's a formula, it might go wrong, but this works fine. So here we've got the z column totals. Here's the y. Here's y1, y2, y3, y4, y5. So we've got everything we need now. So we've got the totals of the columns. We've got y1, y2, y3. So we just multiply those together. And see, it's all just an excuse to show you get more useful bits of Excel, which is I can make here another row to multiply these together, or I can use a very, very useful function I use all the time in Excel. And I think we use it in some of the work on distributions. Sum products. And this sum product, you could just highlight this. So you've got cells G17 to P17. Then you put a comma and G18 to P18. And essentially what this does is it's the same as a dot product, except of course they're horizontal. It's a dot product. It multiplies them all together and adds them up. Well, that's the biggest one we've had so far. So, what is that number? 965,658. So not far off a million by doing that. Okay, so I hope you followed that. I hope that you've managed to get those answers. But as always, please in the lecture ask me if you can't see how to get it in Excel. And maybe even more important, if you can't understand how to turn these things into this kind of expanded notation, then ask, because we're going to assume in the lectures and the textbooks that you can do that. Okay, so now in the next video we move on to probability, but for now, thank you very much as always for watching.